So next we're going to talk about the basinal facies that occur on rim platforms. Generally we're going to talk about the slopes down into the basin. So we're going to talk about the things that happen on a slope. We're also going to talk about what happens on a ramp out in front of the shoal or the barrier facies. So for these slope facies, when you have rim shelves, commonly these can be very steep, anywhere from 0 to 90 degrees, and in some cases where we have currents that undercut the carbonate platforms, we can actually get margins that are steeper than 90 degrees. So remember, much different than siliciclastics. Generally siliciclastics only have slopes of about 4 degrees or less. When we have a rimmed carbonate platform, we can have very, very steep margins. Commonly we talk about the margins, we talk about accretionary margins where we sort of are building up and into the basin. We also have, in this case, this would be what we call an escarpment margin, where we have these very steep slopes and very little generally accumulates on the slope itself. Much of it ends up at the toe of slope, down here, right at the bottom of the slope, where you get these large blocks that will accumulate. Now, the blocks that accumulate here are called periplatform talus. So we get very, very large blocks that can be broken off. I think I showed you some slides where blocks as big as this building can basically be broken off and fall down onto the slope. Generally they will fall just like rock balls. They will slide or glide or basically get turned over and start to bounce down the slope. So you end up with a series of very large blocks down here in this periplatform talus. Remember, on this escarpment margin, commonly this will be cemented. You may even have a hard ground, and if you do, then basically that becomes a surface of bypass. All the sediment that is basically coming off the front of the reef gets bypassed down into the toe of slope and into the basin. And generally you'll end up with, if we're looking on a map view, this is my reef. Okay, so here's my reef. We will see that there will be either channelized flow, or you may get unchannelized flow and just get a series of blocks that'll accumulate here in the front of the reef itself. So this would be the reef, and this would be the slope, and down into the basin. Okay, so you can either have what we call a point source, commonly where you'll have channelized flow, or you can have line sources where the front of the reef periodically breaks off on a series of storms that hit it, or slumps will start to come down here. So the kinds of deposits we get out here are, we commonly will get debris flows, or we'll get turbidites. And just like we saw for siliciclastics, carbonates can make the exact same types of deposits. It's just that now all the clasts are made up of carbonate. So we have turbidites that come out, generally make these fans. The fans may coalesce and make sort of an apron. So that's what we would call this. Down here we get an apron where these sort of coalesce and make a whole series of fans that generally coalesce. And then we get this slope, which also, we can call this an apron, where we have a more than just a point source, where we actually have what's called a line source, and periodically it just breaks off laterally along the margin of the reef. So remember, the slope in these rim shelf platforms, very, very steep, a lot of sediment bypassing as things move down the slope and then get deposited out on the toe of slope. The other thing that I would like to talk about a little bit is, if this is my ramp, and here's my shoal, okay, out here, as we come into deeper water, commonly what we'll see is we'll see a series of rocks that are bioturbated, because all the organisms are quite happy. There will become a point which the organisms won't be able to live, but will still be within what's called storm wave base, most commonly about 60 meters in the rock record, so 200 feet. And then what that means is that these rocks won't be bioturbated anymore, and we'll start to see hummocks. So we'll start to see some hummocky cross stratification in here. But once we get below storm wave base, then we basically just have laminated sediments that are falling out of the water column, accumulating below storm wave base, and we don't generally get a lot of current action out here because of the fact, remember, this is a ramp and we've gone out into deep water and there's not a lot of other things that are affecting this. So just remember, on a ramp we commonly go through a place where it's open marine, lots of fossils. So this should have lots and lots of fossils on it. It's bioturbated, and as we get down deeper into deeper waters, we're still within storm wave base. We start to see the hummocks. You might be interbedded with shale, and then you get into this deeper basinal facies, which is basically mudstone and commonly calci silt. So silt-sized fragments of carbonate, which generally you don't see a lot of laminations in. Okay, so it just looks different, but just remember this nodular bedding is very important. It tells you you're out on the open ocean side of the ramp. So this is the ramp, and this is the rim shelf. Obviously, this is different, much higher energy, large blocks encased in mud, whereas this case, commonly when you get out into deeper water, it's some hummocks or finer grained sediments that are laminated out here in the deeper part.